हेलो एवरीवन, माय नेम इज़ मानस शर्मा। और आज हम इस वीडियो में जो टॉपिक डिस्कस करने वाले हैं वो है डिलीशन ऑफ अ नोड इन बाइनरी सर्च ट्री। एंड इन प्रीवियस लेक्चर वी हैव डिस्कस्ड द सर्चिंग ऑपरेशन इन बाइनरी सर्च ट्री, सो यू कैन ऑल्सो चेक आउट दैट वीडियो. But before starting, if you are new on my channel, please subscribe to my channel. Also hit the like button. Now let's start it. So in deletion operation, we delete a given node which is present in a binary search tree. But if it is not present, then we will print a message that the node is not present. Right? So now let's suppose you have given a node. Then you will check that the given node is present in BST. If it is present, then we will delete that node. If it is not, then we will print that the node is not present. Right? So the first step is we will check the BST. If BST is empty, then we can't delete any node from that BST. But if BST is not empty, then we will perform searching operation. Now in searching operation, there may be two conditions, whether we find the node or not present. So if the node is present, then we will delete that node, or else we will print that the node is not present. But while deleting, we may face three situations, and that situation is node with 0 children, second is node with 1 children, and the third is node with 2 children. So now let's take the case of 0 children. So guys, here you have given a binary search tree, and in this BST you have to delete that node which has 0 children. So here the given node is 4 and you have to delete that node. So now how can we delete the given node? First of all, we will check the node that the given node is present in BST or not. Now here we have find our given node, and then directly we can delete that node. So this is the first case, that the node with 0 children. Now the second case is the node with 1 children. Let's suppose you are deleting a node which has only one child. So how we can delete that node? So here the given node is 14 and we have to delete this node from the BST, and this node contain one child. So how we can perform the deletion operation? So first of all we will perform searching operation, and then we will replace it with its children. Right? So here, after finding the node, we will replace it with its children. So after replacing it, we can simply delete the last node. Right? So this is about the node with one children. Now the third case is node with two children. So let's suppose you are given a binary search tree like this, and you have to delete a node which has two children. So here, let's say if we want to remove this 6 node, and this node has two children, 4 and 7. So here how we can delete the node? So here we have two ways. The first way is we can replace it by left children, or we can replace it by right children. So the first case is we will replace the node with its left children. So after replacing, the BST will look like this. Right? Now the second case is we can replace our node with its right children. So after replacing with its right children, that is we will replace 6 by 7. So the BST will look like this. Getting my point? A bit confusing, right? So why don't we see some more examples? The question is we have to delete 5 from the given BST. Now guys, just pause the video and give a try to this one. I hope you have solved the question. Now let's check how we can delete this 5 from the BST. Right. So the first step is we will search this node in the binary search tree. Here we have two ways. The first way is we can replace this node with the maximum node present in the left subtree or with the right children. So let's see the first way. We find the maximum from the left subtree. So here 4 is the maximum and we can replace it with 5. So this is the one way, or we can replace it with it right children. So here after replacing 5 with 6 we can easily remove this node. Now I hope you got the idea how to delete node from the BST. Now what if I want to delete 12 from the BST? We can't replace this node directly with its children because we also have to maintain the BST property. So the point is we have to find the maximum node from the left subtree, or we can find the minimum node from the right subtree. And I also prefer to use the second approach, that is minimum node from the right subtree. So now we will use this approach in our code. Now let's code it. This is my delete function and I'm writing the first if condition to check the BST. If BST is empty, then it will print the message, else we will perform search operation. Now in searching, we are comparing the data with the root node. If the data is smaller than the root node, then we will search in the left tree. Or if the data is greater than the root node, we will search in the right tree. This is how searching works. Now after searching, we will write the code for our three situation which we see earlier. So here I'm writing the code for node with 0 children and node with 1 children, right? Let me finish, then I will explain the code. So this is the code for node with 0 children and 1 children. तो यहाँ पे क्या हो रहा है, लेट्स सपोज अगर हम इस BST में लीफ नोड को डिलीट कर रहे हैं तो इस लीफ नोड का कोई भी चिल्ड्रन नहीं है, तो उसका लेफ्ट एंड राइट चिल्ड्रन नन है। यहाँ पे हमने लिखा है टेम्प इक्वल्स टू सेल्फ डॉट आर चाइल्ड, मीन्स हमने टेम्प में अपना राइट चिल्ड्रन को स्टोर करा लिया और राइट चिल्ड्रन क्या है उसका नन। देन हम उसके बाद अपने सेल्फ पॉइंटर को भी पॉइंट कराएंगे नन पे, एंड देन वी विल रिटर्न द टेम्प, दैट इज इट विल रिटर्न नन। सो ये हमारा नोड विथ 0 चिल्ड्रन एंड 1 चिल्ड्रन के लिए वर्क करेगा। एंड दिस इज द कोड फॉर नोड विथ 2 चिल्ड्रन। तो सबसे पहले हमने यहाँ पे क्या किया है, हमने लिखा है नोड इक्वल्स टू सेल्फ डॉट आर चाइल्ड, मीन्स इफ वी आर डिलीटिंग दिस नोड then we will store its right children. After that we will use the while condition to find out the minimum node from the right sub, and then उसको हम replace कर देंगे with this node. So this is how deletion works, right? And then ये यहाँ पे return कर देगा self को. Let me run the code, and the code is running perfectly. Give me a moment guys. If I do like this, then yeah. I want your attention guys. Just look at the output. Now here I printed the in order traversal of the tree before deletion and after deletion. We successfully deleted the 100 from the BST. Can you see that? That's all guys, and thanks for watching the video.